As Don mentioned, my name is Ken Taitingfong. I'm a senior information security engineer at Cisco. I work for the Government Trust and Technology Services Group. Been in the InfoSec field for about 17 years. A couple places I work with. Don mentioned AT&T, United States Postal Service, NCSU, Quintiles, which is now IQVIA. I've been a Splunk administrator for about 5 different environments. Some of them are pretty small, like 6 servers, about 10 gig license. The largest environment I ever worked on was a 10 terabyte license and consisted of about 95 Splunk servers. Reason I tell you this is because we're going to get into some architectural discussions, and I can show you why that might be prevalent or why that might matter. So for our agenda, I'm going to explain what Splunk is, what it does, what it can do. I'll show you and explain to you how the Splunk processing language works. I'm going to detail how Splunk works, including some architectural options, as I mentioned, and I'm going to demo some real-world use cases. All right, so let's start off with what's Splunk, right? So let's just pretend this is a typical network. So you've got, your Windows servers. Let me get this pointer working here. Got a set of all your servers, right? Windows, Linux, application, whatever you got, database, your network gear. So back in the day, or maybe even now, you guys still have to do this, you'd have to log into each of these individual nodes to look at the logs, right? So for your Windows servers, you'd have to use RDP and Event Viewer. Linux and Nix servers, back in the day, RSH, SSH. Your application servers might support different kind of methods, and at best, you might have had a syslog server, which you could grep through, right? But Windows didn't really have a native syslog client, so you were kind of halfway there. So for your databases, you kind of needed a connector and some type of viewer. And then for your network gear, you were doing SSH or Telnet, or as a last resort, maybe console. So once you had a connection to all those, you had how many console and remote sessions open, right? And then how easy was it to look at one node and go, all right, I need to compare the logs from this host and look at it on this side? It was almost impossible. So what if you could get all the logs off of all those nodes into a vendor and OS agnostic solution that provided multiple ways of getting this data in? And that data could be structured or unstructured. And the best part about it is you only needed one place to log in to look at all that data across all those nodes. So that's where Splunk comes in. So instead of me logging into all these servers, right? What if I put an agent, which Splunk calls a universal forwarder, on my Linux and Windows hosts? And the universal forwarder monitors all the logs that are being written to disk, and then it forwards it off to Splunk. But what if I had a host that I could not install a forwarder on, right? But it had an exposed API. So with Splunk, I could just pull the API, get it in there, and then I can query it, whenever I needed to. Just because I can, you may run into a situation where you could just open up a TCP and UDP listener right on the Splunk host and have your nodes forward straight to those ports. And then what if I installed an app called DB Connect right on Splunk host that allowed me to query every single database in the environment and pull that data in so I can compare it on that side too, right? And again, the best part, you only need to log into one spot to take a look at every single one of those sources. So for those of you that have never seen Splunk, you may be thinking it's okay, so it's just a GUI for my logs, right? But seriously, what else more can it do? So if I wanted to, sorry, this is kind of small, but don't worry about the data. I'm going to get into a demo later. But this is a view of some of the data that's already in Splunk in a tabular view, right? So this is a query for all the failed logins to my Windows host. It's time charted out into time chunks, and I'm looking at it again in the table view. But it's easier for me to look at it as a line chart, right? So instead of going through every single line there and looking at the counts, I kind of want a visualization of what's going on here. So see the peaks and valleys, maybe that can indicate a problem. But for whatever reason, I want it as a pie chart. It can do that too. And then what if, in another scenario, I wanted to geolocate all the external IPs that was touching my perimeter, right? Managers love that stuff, by the way. So put it up there on a map, and then I can say, like, look, you can see China's hitting us, but in this case, it's actually a little different. It's the US, of course. But this is kind of the default view. This is where you're going to work in. So this is a view of when Splunk has your data. It's already parsed out in key value pairs. And this is the search and reporting app. So this is what we're going to be looking at in a couple minutes here. And one of the other capabilities that Splunk has is that I can write alerts that say when a certain criteria is met over a certain period or whatever criteria I want an email alert to kick off and go to my ops team or any other thing that I can script out. So that's what Splunk can do, and that's just some of the really basic stuff that it can do. So I'm going to get into how it kind of works. So once you decide how you want your data to go into Splunk, it hits, this is a really simplified explanation, by the way. It's going to hit a couple of queues and some parsing pipelines, and during this time, your data is appended or prepended with a bunch of metadata. And then when it's going through some of these pipelines, one of the things it's done is it's source typed, and then it goes into this guy here, which, oops, that's interesting. Last server on the right, which is called an indexer. This is essentially where the data lives, right? So as a Splunk user, I'm going to log into something called the search head, which is where I write my query language, my search, which pulls it out of the indexer. So again, very, very simplified kind of explanation of how it kind of works on a high level. And then here's an example of what this kind of looks like. Sorry about that. So on the left-hand side here in orange, you have your fields. And then you put a comparative operator in the middle. So equals, not equals, less than, greater than, less than equal to, greater than equal to. And on the right is your value. So what this search is it's going through my Windows logs. It's looking specifically at the Windows security logs. And here, my comparative operator is not equal to. So I'm saying the event code is not 4625. 4625 is bad username password. So I'm looking at every other event than bad username password. I'm looking for a user called Amber, and I have a Boolean operator, or, and I'm looking for another user named Nicholas. And then I'm doing a transformative search here where I'm saying time chart all this by the computer name that they're touching in the logs. Make sense so far? All right, we're going to get into a couple more examples here, so don't worry about it if it's a little crazy. But as soon as I run that, this is the actual output. So again, it's a time chart of all the events in my Windows logs, and again, I'm sorry, it's kind of small. And then you may be asking, it's like, how does Splunk parse my data, all right? So I have all these different data types. I've got applications, I've got network gear. How in the world is Splunk going to know how to parse all that? So one of the things you're going to hear a lot with Splunk is this concept of apps. So an app is just a bundle of configuration files. So a lot of these configuration files just tell you in this data type, which is the source type that we mentioned earlier, this is going to be the field, this is going to be the value. A lot of that is regular expression matching. And a lot of these apps are written either by Splunk or the vendor, so hopefully the vendors know how to parse their own data. But a lot of the other apps are also community driven. So just random person that wants to publish an app to Splunk.com, Splunk will actually give it a look over, and then it's available for anybody to download. The majority of these apps are on Splunk base, and 99% of them are free. Splunk is not free, but the apps are. And then again, as I mentioned, when your data is source type, Splunk knows how to apply those specific extractions and other transforms based on regular expression and other criteria to normalize that data. And then when the extractions are complete, the user is kind of given a nice view of their parsed key value pairs, which makes it really easy to search. And again, this whole concept of apps. Apps can also come with visualizations such as dashboards. There's a lot of apps that provide just a whole lot of eye candy, including the ability to parse that data. And as of this writing, there's over 2,000 apps available on Splunk Base. But every once in a while, you'll run into a situation where there is no app to parse your data because you have something, right? Or no one wrote one. You can write your own. It's not that bad. If you know regular expressions, you can parse your data. So everybody have a high-level kind of understanding of what Splunk is, what it does? Because I'm going to get into some architectural options here. So this is a single server node option, which Splunk will run in, right? Where the search head and the indexer are the exact same machine. And I have all of my data inputs going to it. So obviously it's not data redundant, there's no fault tolerance. It's very basic. So little secret, I'm running Splunk right on this laptop, single instance node, right? So in this option, I'm gonna actually put a few more indexers. What I can do is have my universal forwarders spread their data across all those indexers for a little bit of load balancing. The problem with this is if I lose any one of my indexers, that data is gone. And there's not really a way to recover it. So what Splunk provides is this option called the cluster master. You might hear it called the master node. So the cluster master clusters all the indexers, and now what ends up happening is when a data input comes in and is indexed, it's actually copied over, depending on what your configuration is, to all the other indexers. So depending on how you configured what's called the replication factor, I can lose X number of indexers and still have access to all of my data until I can stand up some additional indexers and get that data replicated. So now I have data redundancy, right? So the other thing I can do is I can use something called the deployment server, which allows me to centrally manage the configs on every single one of my universal forwarders. So I can publish apps that say, this is how you're going to send in your data. Load balance across these indexers, use encryption, whole lot of other different options. And I'm doing it all from this one spot instead of having to touch every single node for those configurations.
What is that called?
The deployment server. Mm-hmm. But in this option, the other problem is I got one search head. So if that search head goes down, no one's searching any of this data, and you've got a really expensive solution that no one's being able to do anything with. So if I add a couple more search heads, I can cluster them with the server on the far left, which represents something called the search head deployer. So now, anybody can log into any of these three, but if we want to do it right, I would put this behind a load balancer and expose a VIP, and then your users would hit the VIP, and they would never know what search head they were on. Best part about this is that the knowledge objects are actually replicated across all the search heads. So your saved searches, your alerts, your dashboards, all that. Doesn't matter which one you log into. As soon as you save it, it's going to get replicated to the other three. So you get bounced onto the second search head, all your stuff is still there, right? So as good as this is, though, this is still not site tolerant. So if your entire Splunk site goes down, it's totally unavailable, right? It's toast. So this is what we call a multi-site cluster. So essentially, however you want to distribute your two sites, you have a high-speed link between the two. But now you have a search head cluster that spans all the sites. Your clustered indexers span all the sites. And then depending on your architecture, you could have your search head deployer, your deployment server, and your cluster master in one site or both, whatever your needs are. And then you can have your forwarders only forward to the indexers that are at that site. You don't have to, but if your network guys are like, keep your additional data off my WAN, you could. But now you have a fully redundant site, both in a site perspective and a service perspective, which is what a lot of people do. The cool part about this is that no matter how many servers you stand up, Splunk doesn't get an extra dime of it because Splunk gets paid by the license. So if you have a 10 gig license and you have 100 servers, which is way overkill, Splunk's not getting an extra dime because of that. So, also if you have a 10 terabyte license and you have one server, it's, you're way underpowered for that. But Splunk's not getting, any extra money just because you just keep spinning up servers. And the last option is Splunk Cloud. Splunk as a service, Splunk as a platform. I honestly don't know that much about it. I know very little about it, but there's a lot of different customers that kind of go in that option. One thing I do know about it is you don't really have a whole lot of control about it, over it. You put in tickets when you want stuff in there, and the service provider handles it for you. So any questions before I start bringing up Splunk and start looking at data?
Is the license based on the storage?
No, thanks for asking. License is based on how much data you ingest per day. Splunk literally sent an email out probably less than a month ago that said they're changing the way the licensing model works, so there's more options. I honestly did not look that close at it, but the typical license model is how much you ingest uncompressed per day. So it could get very expensive when you start pumping in all, basically everything. Or as one of my managers said, Splunk it all. We paid for it. So, just keep that in mind. So actually, this is the use cases. So I'm going to pop out of my presentation here in a sec. Oh, sure. Yep.
The multi-site orchestrator, whatever it's called, where does that reside?
You can do whatever you want. So like my group right now, we have site 1 is on-prem and site 2 is in AWS. We were going to do a multi-site at NC State, and it was just going to be between 2 data centers that were actually on campus with a high-speed link between them. So if, I don't know, half the campus got nuked, we still have like the other. I mean, they were like right there. It was kind of weird, but.
Would it just be at one site or the other?
Yes. So the cluster master is actually not part of the site. You only need one that can control all the indexers. There are scenarios where you could stand up multiple of the deployment server, the search head deployer, and the cluster master. It just really depends on your use case. So that's kind of the cool part about Splunk is it's really flexible. If you only want one thing to log into to send out your configuration files, you can. But if you have a use case, like really, really big Splunk environments have multiple master nodes, multiple deployment servers, multiple search head deployers, just because they're so big, right? And they need to control what goes where. So I'm going to pop into Splunk here, and I'll blow this up a bit here. So I'm going to go through some use cases. So these are some of the real-world use cases that I've had using Splunk all these years. So first use case, Ken comes into work on the morning of the 26th, September 26th, and saw his account had been locked out. The AD account lockout policy set to 5 bad passwords, and he's not sure where it occurred or which machine it originated. So we have all of my Windows logs in a index called WinEventLog, right? Source equals when. Sorry. It's trying to autocomplete for me because it's got my search history in there, so it's kind of confusing me. And that's supposed to be an equal sign. And what I know is, we mentioned this earlier, event code 4625 in Windows is bad username and password. And I want to look at user Ken. Sorry, this is it. So you can see that's a pretty simple search, right? So I know where my Windows logs live. I'm looking at the Windows security logs. I know what event code I'm looking for, and I know what user I'm looking for. Let that run. Boom. So account lockout policy is 5. Just float that over there. I got 5 events on 11 a.m. on the 26th. So I'm going to drill down a little bit just by clicking on it, and now I'm only looking at those 5 events. And without even looking at the logs themselves, I can scroll down here where the data's parsed, and I got 3 machines that showed up where Ken potentially, or somebody pretending to be Ken, logged into and failed at password attempts. That took me like 30 seconds to find that out. So this is stuff that really helps like help desk, right? So one of the real world use case scenarios that we had was when we first rolled out Mobile Iron at one of mobile jobs. When people change their passwords, I mean, like mobile devices were just locking up their stuff all day long. And it was so easy to just pop in here, pull up a quick search for a user and like, yeah, this is Mobile Iron or this is not Mobile Iron. I can see this guy changed his password like 30 minutes ago. It's probably not synced. That's probably what's causing it. But again, it's, it took me only a couple minutes to search this. Any questions on that? All right. Use case number 2. The network ops team wants to ensure all DNS requests are going to the internal DNS servers. They would like a report of every host that's querying the external DNS sources and where they're trying to go. So I have some sample ASA data in here, and I threw that into an index called network. Source type, Cisco:\ASA. And I'm going to cheat so you don't see me fat finger some stuff. So destination port, of course, 53 for DNS. In the Cisco ASA logs, the protocol is actually in a field called transport. So we're looking at transport equals UDP. And for this demo, and for the rest of the demo, what we're going to see is, my internal IP space is going to be in the 172.16.0.0/12 range. And then I'm going to say stats count by source IP and des IP. So what I'm saying here is run a statistical function, count the number of times the source IP and destination IP matches query. And I have a lot, right? So source IPs on the left, that's all my internal IPs. All the external IPs on the right. A lot of people querying Google. So this gives someone, the network team like, hey, look, all these people are pointing to Google instead of internal DNS servers. Again, this took me a couple seconds. It's not quite finished yet, but it's not really hard to pull off. Any questions about that? Oop. All right. Stop me at any time, guys. So third use case scenario. The security team believes there's an infected host on the network sending junk mail. They believe the email worm isn't smart enough to discover the internal email address or email server address. So they would like to know which hosts on the network are sending email directly to the internet. And also, did it get picked up in AMP? And since we're Cisco, we have AMP. So I'm going to stay in the firewall logs here, but I'm just going to change the destination port to 25, of course. And we're not looking at UDP, we're looking at TCP. Same thing with the destination addresses, right? We're not looking at internal addresses. I want to see where all my stuff is going externally. And let me make sure I didn't miss anything. All right. Got a handful. And it's still running. But these guys are sending email directly out to the internet, bypassing the internal email servers. And why? So the second part of that question was, did it get picked up in AMP? So I'm just going to duplicate this tab. My AMP logs are actually going into a different index called eStreamer. And I'm going to cheat because that was in there. So I'm saying for my source IPs, it's going to be a list of the IPs that showed up on the first page. Let's see what happens. And there we go. 8,135 events. And if I scroll down here, they're all coming from this one guy right here. So he's infected. And I was able to look at both the ASA logs and the AMP logs in about a minute, minute and a half, something like that, right? Now I got some information for the security ops team. I'm like, this guy probably needs help. So, any questions about that? Okay, all right. Use case 4, the security team would like to know when someone attempted to run a cross-site scripting attack against the externally exposed websites. However, they want you to exclude the internal vulnerability scanners and would like an email alert to trigger when this occurs. And they would also like you to resolve all the offending IP addresses in DNS. So that's one of the cool little options that Splunk can do is actually resolve DNS, resolve IP addresses. So let's do this. So my access combined logs are in a index called web. And again, I'm going to cheat a little bit here. So what do I know about cross-site scripting attacks, right? They typically have the less than script, greater than, alert is going to be in the string. I'm not going to get into the whole HTML, ASCII versions and all that other stuff. This is going to just be really simple. In this case, I know my access combined logs uses a field called client IP for the source IP. And again, I'm not looking at my internal IP addresses, so you see the bang equals. And then this part in the middle, look up DNS, look up client, blah, 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 blah. All that is saying resolve my client IP addresses. And then I'm going to output it to a table. And I apologize, this one actually takes just a little bit longer because it's going to try to do DNS lookups. There we go. Got the 64 address, which belongs to Qualys, which is scanning my external web, my websites. That might be normal unless you don't use Qualys. So, you know, that is something that you could set up there. Now, part of that was the ops team said, hey, I want an alert on that, right? So I'm going to save this as an alert and then just fill this out. So I can set permissions. I can set how often it runs here. Run it weekly, daily. You can run it in a cron. Here's the triggered actions. This is where I would say send an email. And I'm going to send it to all these people. And I'm going to have the subject. I can include the results in there. I can embed the results in a CSV and attach it to there. All sorts of options. And any questions on that? All right, use case 6. Manager for the marketing department wants to know if Victor has been really logging in or forging his timesheet. She'd like a report of all of Victor's login activity. You say, go get a warrant, Karen. Snitches get stitches. Because, I kid, because this really happens. Like when you start getting something like any type of log aggregator, and you start getting the logs of everything, and people realize you can see a lot of stuff, people start coming to you. And especially managers, when they're having problems with their subordinates, they want you to pull web history. They want you to pull in login IDs, all sorts of stuff. The reason I bring this up is you're going to see that scenario and the other scenario, which is people realize that they can shove all their data into Splunk and they don't have to log into a whole bunch of different places to see it. So you really need some strong policies around the who, what, when, and where, and the how of who gets access to this, how the data gets extracted, you know, what roles you want to set up that has access to what indexes, all that kind of stuff, right? Because you will get inundated with a bunch of people who was like, ooh, the new shiny, I want to see this data. So some final notes, as Don mentioned, you can actually download Splunk for free for 60 days. Again, you just drop it right on your laptop, and you can actually just Splunk your laptop if you want to see what that looks like. So after 60 days, the Splunk product actually goes to a free version, and there's a bunch of features that get disabled. And you can just go right to Splunk.com, register for an account, and pull it down. Runs on Linux, Windows, Macs, and a couple of versions of Unix. Splunk has great documentations at docs.splunk.com. I'm going to tell myself I live there almost, trying to figure out why my queries aren't working, why things are broken. Same with the community-based forum, answers.splunk.com. I actually probably live there more, sorry. We also have a local Splunk RTP users group, and that's the URL if you want to sign up and find out when they're meeting. They've met like downtown a couple times, they kind of move around a little bit. Splunk has a Slack channel. They actually have a Slack channel called for newbies or something like that, where you can literally ask any question in there that you don't know about that to learn more about it. And last but not least, you can just go to that website and you can request a 10 gig dev license. You may see a 50 gig dev license. There are some severe limitations with that, so read the limitations on those before you choose which one. I've never had anybody come back and ask why you want a dev license. The big caveat is it's not supposed to be used in production, right? And that's really about it. But I actually put the dev license on this laptop. I think it does expire every 60 days. You got to ask for a new one. But you can seriously try it out in a couple of minutes. Download it, install it, Splunk your internal logs, and away you go. So thank you. It's my email address. If you guys want to reach out to me and have any questions, feel free to ping me. Any questions? Sir? Yeah, so it's kind of an interesting conundrum because most of the times people who use Splunk have terabytes, maybe petabytes of data, right? How in the world do you back this up? A couple of schools of thought. You either make your data so redundant that you don't ever have to back up, which is what a lot of people do, right? With the multi-site clustering, clustering of the indexers, all that. So you have enough indexers that I can just lose like half of them and still have access to all my data. So I never have to back it up. That's not always that great, especially with auditors, when you try to tell them like, no, my data's redundant, I promise. It's not backed up though. The other option is Splunk has this concept of frozen buckets or frozen archive, where you can mount another mount point on your indexers and say, after it reaches a certain size or a certain age, to have it go into those volumes. So that's all offline storage. Once you put that data in frozen, it's not searchable until you thaw it, which is another process. So some people do that. That's some of the options. I've seen people try to use like third-party solutions like Avamar, and like Avamar just could not handle it. So either make it really, really redundant, or archive your stuff into frozen and kind of handle it in that method. Any other questions? Sir? Yes. So, a couple different things.
Repeat the question, please.
Oh, sorry. The question was, is there any strategy around pre-filtering your data so you're not just getting a bunch of stuff into Splunk? So, a couple strategies. As a Splunk engineer, you can sit down with the data source owners and say, okay, do we really need all your stuff? Or can we just kind of get some stuff, right? You can run into some situations where like the system owner has no control over what goes into their logs. And if you decide to ingest it, you're going to get it all. There is a function of the server or a Splunk component called a heavy forwarder, which is just another Splunk instance. I didn't go into it. But you can have all your data go into the heavy forwarder. And from the heavy forwarder, say, I want to null queue all this stuff and not forward it on. And then forward it on. And the part that counts against your license is the part that goes from the heavy forwarder to the indexers, not the stuff that hits the heavy forwarder. So it's a nice way to pre-filter. For servers, you can actually go into the heavy forwarder configs, the universal forwarder configs, and you can do things like blacklisting, whitelisting of events. You can write regular expressions and say, I only want to pick up this stuff, or definitely drop this stuff if it matches regular expressions. A couple different ways to do it. So honestly, the best thing to do, especially in an Splunk environment, is sit down with your system owners and say, okay, like, what do you really need? Because I don't want all this, I don't want your debug information, right? But ultimately, it kind of also plays into a weird situation where you become like the data custodian and they're the data owners. And if the data owners want all their stuff in there, it's like, all right, do I give it to you? Or, or do I like put my foot down and say, no, I don't want your debug information. So it's kind of an interesting situation to be in. But yeah, there's a couple different ways to deal with that. Yeah, sure. Anybody else? So depending on if you have, the single server instance, it's the same box, right? Or in, whatever the split environment you decide to do. All your users log into the search head to run the queries. So the search head just says, put in your query, go out to the indexers, pull that data back based on whatever you wrote. Splunk supports local accounts, LDAP. They also have this other option called scripted, which we used at NC State, which was basically write your own script to pull in like your IAM data and create roles. It was nasty, but it worked. But based on that, you can create roles and do RBAC. So I can say, all right, you're a network engineer. You're only going to be able to access the index network. And you're not going to be able to access index equals security, which is all my security stuff, right? Same with the web, your web admins, your Windows admins who never look at the Linux stuff, et cetera, like that. You can do that. You can even get more granular and say, you know what, this is the only search queries that you can actually run. that does not scale well at all, and I know from experience, I would highly avoid doing that. So it does mean that you have to plan really well to make sure you got the right data going to the right index if you're going to lock it down by index, but it is the easiest thing to do. Thanks. Anybody else? Yes. So I didn't really look too close at the new ones, but it had something to do with, I think they looked at like your average over a course of a time, and they kind of build you based on that. That was like one option. What Splunk kind of finally realized was they're not necessarily getting all the customers they want because it's not cheap, right? So you want to pump in a bunch of data into it, but you've got to pay for it. So they wanted to be a little bit more flexible. But that licensing model, like I think I mentioned earlier, literally came out like a month ago, and I did not look at all that close to it. But if you look up just you Google Splunk license, it's got to be out there. Oh, sorry. So the question was about what Splunk calls premium apps. So these are the apps. So I said 99% of all the apps on Splunkbase are free. The less than 1% are the premium apps. So there's something called like Splunk Enterprise Security, which is the SIM bolt-on, which provides your correlation engine, a bunch of data models that are already created, pre-built alerts, and all this other stuff that you bolt on top of Splunk Enterprise. The licensing model for that works based on what you're already ingesting, but you don't pay like 100% of what that is, from what I understand. Some of the other premium apps, there's one called Phantom, which is now in the SOAR category. A lot of like SOC playbooks and stuff out of that. They used to have a PCI app, but that kind of got rolled into enterprise security. User behavior analytics, that's one of their other ones that they have, and it ties directly in enterprise security. If you guys are looking to use Splunk as your SOC tool, highly suggest enterprise security, but it is not that user-friendly from an engineering standpoint. There's a lot of work that needs to be done with it. But it is pretty powerful. It's pretty cool. But again, it has integrations into both like Phantom for your playbooks and UBA for your user behavior analytics. But all that stuff costs extra. So, anybody else? Sure. All right. Well, thank you for your time, guys. Appreciate it.